Hello, Jeremy here. In this video, we'll get some sprites moving around the screen. This is the very basics of moving a character in a game. The idea is to change the position of the sprite on the screen based on where the character is. We'll start by showing how to move a sprite around based on where the mouse is, as that should illustrate the common problems. Alright, let's pull up the code. Okay, so here we are. I had to add the multiplexer back in to do the intro, so let's go ahead and move that back. We should be able to pop these over back into the group here. So let's just save that and run it. Yeah, good. Okay, so for this, we're going to tie in a sprite to the mouse movement. So what we're going to do is, no, we shouldn't update image, even though the image will be what we're going to move around. Okay, let's just do this the cheap way first, just to show. So what I want to do is I just want to mess with the dragonfly. So let's do this. Let's do the dragonfly only. And then we're going to modify the dragonfly's rectangle, cause it to move around based on the mouse location. So what that's going to look like is in the update, we're going to update the dragonfly down here. We're going to say dragonfly's rectangle, dragonfly rect equals dragonfly dot rect. Let's actually just do this. X, Y, width, height. Okay, so I'm going to make a saying about the naming. Usually you want to have good names. You want to have like X, Y, width, and height. This is usually good practice. And there's nothing wrong with you keeping it as it is, and I'll keep it as it is. But typically, one-letter variable names are not that great, because you don't want to have like A, B, C, D, F, Q. It's hard to keep track of what those mean, and it's pretty. In here, width and height are better than W and H. Typically, in the context where you would use something like this, is you would say, well, it's obvious it's width and height from the context of being a rect. And as long as I'm using width and height immediately in this area, like I'm saying, I want the new position, so we want to go is event.height equals gain.mouse motion. Yeah. Then we do this. We want to say x comma y equals event dot hosts. I believe that's what it was. And we can look at the canvas and see what it actually is. So then dot post, yeah. Okay. So this is a possibility, and then we can make the dragonfly dot rect equals a new rectangle x comma y width comma height. So this is the code that we want to write. However, you see that width and height is being used immediately in the same. So this is okay. We know the context of what's going on, so it shouldn't be too bad. The problem is when we use width here and somewhere else in the code we're reusing W, somewhere way far away. You'd have to imagine this is thousands of lines of code, and W is used over and over again for those thousands of lines. It's going to be hard to figure out what it means. It could be width, it could be weight, it could be other stuff, water. It could be anything. So typically you want to spell things out, but context matters. Like it may be better to say dragonfly X, dragonfly Y, dragonfly width, dragonfly height. That would spell everything out about those variables. So keep in mind context is important. And if you make a choice like this and you use like a single letter for something that's immediately nearby, and you end up adding more and more lines of code, and 100 lines later you're using W still, you should really consider renaming it. So it's usually better to do stuff like this. Width, wait, width, height. Now we want width here. Okay, so that's the first thing I wanted to say about naming. Second thing about Python is you can use underscore to mean I don't really care about the name with this. This is saying that I don't want to assign those two elements, but I want to assign width and height to the rectangle. This way, I don't assign X and Y here, I only assign it here, which is based off of the mouse cursor position. This is what this is doing. So we are making a new rectangle based on the mouse cursor position, and we're reusing the width and the height of whatever the dragonfly image was. So now when we draw the dragonfly in this step, we will get the dragonfly blitted to the screen in a new position. So let's go ahead and try this out. There's the dragonfly. And you see it's working, but what's going on? Why is this like repeating? It's not moving. Well, it's moving, but it's leaving behind this trail. What's going on is we're not clearing out what was there. So that's what we need to fix. What we can do, just to show you a not so great way of doing it, but it would work, is no, I'll do it. I'll do it the right way. But I need the background. For this. The background is going to be black, I guess. Or we could use the pool as the background. No, it's not big enough. Okay, what I'm going to use as a background is, let's make the episode images / want to grab the episode. Copy that out, paste it in. All right. So this is the title screen for the episode. As a thumbnail, whatever you want to call it, and we will put it at 0, 0. So that'll be the background. Okay, so what we are going to do is split the background and then draw. And you'll see that it will have the effect that we want. So screen.blit background image. And we can put that up to sport. Let's try it. Now it needs a destination. Hit 0, 0. Okay, so now you can see that we are able to get it to move around. So what's happening is we have the old position there, then we blit the background over it, and then when we move it, we're seeing it update. Essentially, all the old ones are being erased, and that's what's happening. Okay, so that works, but it isn't efficient because we're redrawing the whole background every single time we do this, every single frame. In fact, we're redrawing the background, and that can be a problem. So what Pygame implements is actually I'll show you this in the on my tablet, what it does. So what Pygame does is, let's see here, we need a paintbrush, and we need to actually have it be a reasonable size. Okay, good. So here we go. We have the screen. Straight as usual. I'm like a bona fide artiste here. So we're drawing the sprite here. Here's the sprite's rect. The position is here in the upper left-hand corner. So when we move it, let's say we want to move it down here, with the new position in the upper left-hand corner here, what it does is it remembers this rectangle from the previous draw, and it only blits from the background. So I'll have a background image. I'll have it like a big Pac-Man. Like that. So it remembers all of the pixels here. Well, it remembers that this was drawn over from the previous frame. It copies, it blits from the background over here. So it restores that, and then it draws on the new rect. So instead of updating the whole background, we only update the old region that was drawn over, and then we draw the new region. So this is more efficient because we only redraw what was covered before. So to do this, we will use Pygame has a group. Pygame group has a clear function, and we will use the clear function to do this functionality. So I'm going to internet search Pygame group group.clear. And it gives me the Sprite documentation, so I'm going to search for clear. Yeah. Find me the clear. Find me the clear function, please. Clear takes a surface. And a background. So we're going to use the screen and then the background. Okay. So we should, instead of doing the split, we want to do group.clear screen, background. And this should do the clearing before we do the draw. And then we will see how this goes. Okay, let's try it. Let's be pygame.surface, not image. We also need to go back to the Emacs because I'm really good at remembering this stuff. Okay, so we do clear the background, so group.clear screen background. So we're going to clear the screen, and anything that we need to restore, we're going to use this image to restore it. Now we need to say background.image instead of, this will give us the surface that pygame needs to use. Okay, let's try it. So you see the background is the beginning of programming thing. It's a little off though. Oh, that's interesting. You can see it redrew from the image. I have to show that background image first, split it first. Anyways, you can see what is going on. Now that's working properly, and we're only restoring the what was underneath the sprite. So this is the bare necessities to create motion for a game. I'm going to cut the episode here. Next time we will do animation. We will show how to do animations. That way we can do basically character movements, walk cycles, things like that, where this doesn't look like the dragonfly is moving. It just it's funny looking, but yeah. We'll do animation, and we can make things look like they're walking or they're flying or any number of things. So that's going to be the next piece. Actually, yeah. Well, that's going to be the next piece of doing the animation. And then the next episodes we can take what we did and extract them into its own class that we want to be able to move around, make like our own movement, things that can move around. We'll make a class for that. So that's it for today. I will get all that ready, and hope you guys are looking forward to the next episode. Have a good day.